to follow up on our derivatives of e to the f of x, we're going to see what the derivative of ln of f of x is. So that's today's topic, and it's the 7th of October, and fix your table of contents, please. Okay, let's review the graphs of e to the x and ln of x. We showed, or we reviewed that last time. Very important, when I plug in 0 for x here, I get 1 for e to the x. So e to the 0 is 1. That's the graph we showed last time. And then you have to recall from pre-calculus and algebra 2 that ln of x and e to the x are inverse functions of each other. So remember, if I have my L shaped here, and I go and I go here, I get that function. Yeah? Oh, wait for it. Look, I have a pretty little, beautiful. Okay. Life is better with a little fuzzy slip here. So let's see. If I have this function here, and here's my e function, so I'm going to slip this behind me right here, and then I do the flipping, x becomes y becomes x, and you'll see that that's that function. Okay? So, inverse functions of each other. They undo each other. Important to write ln of x and e to the x, inverse functions of each other. They undo each other. And here's some examples here. Right? E to the ln of x is x. Ln of e to the x is x. E to the ln of anything is just that anything. Ln of e to that anything is that anything. They cancel each other out. It's like square root and square, or adding and subtracting, etc. So stop the video and take those notes. And let's go on. So we're just reviewing for a bit now. These are two pretty green and pink things that you should commit to memory. I could talk about them, but I could just also be quiet. What are the chances of that happening? These are going to serve you well to simplify your life in calculus. And these commit to the memory and to your soul, both. Not just your memory, but your memory and your soul. Internalize them. E to the 1 is e to the 0 is 1, ln of 1 is 0, ln of 0 does not exist. Go back, look at the graphs to understand that. These are things that you have to know from last year. So put those in your notebook. Okay? And let's see. Okay? Before I tell you what the derivative, this is what we're shooting for today. What's the derivative of ln of some function? And let's just make some connections here. The derivative is just the slope of the tangent line. So it's going to be something really largely positive. It's going to still be positive, but a smaller slope. Still be positive, smaller, smaller, smaller. So the rate of change is really fast, positively, and then it's still increasing, but it's a smaller rate of change. Understand, it's just the reciprocal of that. Positive rate of change, but I have a small slope, and then the slopes are getting bigger. Okay, so that's what we're looking for today. Before we build it up, we're going to use one fact. E to the ln of x is what? Cancel, cancel. E to the ln of x is x. So the derivative of this guy should just be the derivative of x, which is 1. And that's what I'm doing here. The derivative of that is just the derivative of x, because x is e to the ln of x. And what is the derivative of x? Well, it's just 1. You know that from before. So take these notes down, and I'm going to use this fact in the proof of figuring that out. Okay, so let's see. Before we get, well, here, this is going to be the punchline. But let's see what happens. The derivative of this, well, I just did it from above, it's 1. Okay? But I'm going to use this and ignore this for a bit and pretend I don't know how to simplify this yet. Okay? So I keep the right-hand side the same. And then I'm just going to do my chain rule. Candy, wrapper. Candy, wrapper. So what's the derivative? It's the derivative of the wrapper times the derivative of the candy. And I just have 1 on the right-hand side. So internalize that. And then I'm going to go back. What is that? That's just x. What is that? I don't know yet. That's what I'm looking for. And 1. So understand that. And you know what? If that's what I'm looking for, use Algebra 1 skills, divide both sides by x, poof! The derivative of ln of x is 1 over x. Okay, copy that and we'll continue on the next video.